In these next couple of readings, we will go over archaeology in regard to human evolution. Chapter 4 will cover Homo erectus and Neanderthalensis, the first being the Ice Age or the Pleistocene period. Then before Neanderthals in Part 1, Part 2, Culture, Neanderthalensis, Part 3, Society, the Neanderthalensis. Chapter 5 will cover the origin of modern humans, the first being early modern humans, the second being modern human migration, and the third being Upper Paleolithic artwork and subsistence. Chapter 6 will cover Australia and America. We will go over in Part 1 East Asia and Australia, in Part 2 America or the New World, and Part 3 America, the New World. In Chapter 7, 8, and 9 we will cover the phenomenon of agriculture and the importance of the Neolithic Revolution, that being the agricultural revolution. From Homo erectus to the Neanderthals occupied Europe and the Middle East between 175,000 and 30,000 years ago. After reading, we will understand the oxygen isotope glacial sequence, the spread of hominins through Europe and the characteristics of the European Lower Paleolithic, the major anatomical features that characterize Neanderthalensis, the three major theories of the evolution of Neanderthalensis, and the evidence for Neanderthalensis stone tool technology, hunting, use of fire, burial of the dead, and artwork. From here on, we will refer to Neanderthalensis as Neanderthal. Ice Age, Pleistocene period. The picture of Neanderthals as hulking ape men dates back to the year 1908 and the discovery of the Old Man of La Chapelle aux Saints. The La Chapelle fossil was the most complete skeleton of a Neanderthal ever recovered, and it provided a unique opportunity to understand the characteristics of this intriguing hominin. The task of analyzing the skeleton fell to Marcelin Boule, a prominent paleoanthropologist who came to the job convinced that Neanderthals were a degenerate side branch of human evolution. Not surprisingly, the portrait that emerged from that analysis was a hairy, stooped creature. It is a picture of a Neanderthal as a stooped, hairy brute. You can notice in the picture a club grasped firmly in the Neanderthal's right hand. Subsequent studies, however, showed that the study had largely ignored the effects of arthritis and other pathologies on the posture of the fossil. Contemporary studies of Neanderthals paint a far more intriguing picture of a hominin that is in numerous respects similar to modern humans, but at the same time is distinctive. In many ways, the dramatic picture of Neanderthals as our apish ancestors has been replaced by the image of Neanderthals as an enigma. In this chapter, we begin by examining the environmental record pertaining to the Pleistocene, or the Ice Age. We then pick up where we left off in the last reading to follow the record for the continued spread of populations of Homo erectus into Western Europe. We also look at new developments that begin to appear in the archaeological record toward the end of the Lower Paleolithic, around 500,000 years ago, or 500,000 years ago. We then turn to the Neanderthal fossil record and offer an extended consideration of the archaeological record of Neanderthal behavior and society. In regard to defining the Ice Age, the evolution of Neanderthals took place within the context of the geological period known as the Pleistocene, or the Ice Age. The boundary between the Pleistocene and the preceding Pliocene era is fixed at almost precisely 1.8 million years ago, although geologists are considering moving the boundary back to 2.6 million years ago. The Pleistocene is characterized by periods with a significant buildup of ice sheets known as glacial eras, and periods during which the ice sheets subsequently retreated, known as interglacial eras. Geologists developed the geological timescale, and they first developed a record of Pleistocene climate change on the basis of features of the landscape. One such feature is the terminal moraine, a characteristic raised ridge that formed at the point where the glacial ice sheet reached its maximum extent. Cape Cod in Massachusetts is a classical example of a terminal moraine. By looking at such features in both North America and Europe, Geologists developed a glacial chronology for the Pleistocene involving 4 major cycles of advance and retreat of the ice sheets. In Europe, the 4 major glacial advances were named from the earliest to latest: Gunz, Mendel, Riss, and Würm. In North America, the last 2 glacial advances are known as the Illinoisan and the Wisconsin. The bottom of the sea might seem to be an unlikely place to search for a record of the advance and retreat of ice sheets, but analysis of cores drilled from the ocean floor have revolutionized our view of Pleistocene climate change. The development of glaciers is only one element of a global process. As glaciers build up, water is locked up in ice at the expense of water otherwise held in the oceans. When glaciers advance, sea levels drop, and when glaciers retreat, sea levels go up. During some past periods of glacial advance, the global sea level was close to 140 meters below what it is today. Today's sea levels reflect the fact that we are living in an interglacial period. Analysis of cores drilled from the seafloor allows scientists to measure and date fluctuations in the amount of water in the ocean and thus develop a global thermometer for the Ice Age or the Pleistocene period. The secret behind this thermometer is foraminifera, or tiny organisms that live on the surface of the ocean. The skeletons of these organisms are made of calcium carbonate, which absorbs oxygen from seawater and drifts to the seafloor after the organisms die. Over millennia, the seafloor deposits incorporate a continuous stratigraphic sequence of foraminifera. A core drilled out of the seafloor can recover a sequence of foraminifera covering millions of years. Such sequences can be dated by the uranium series method. Foraminifera absorb 2 isotopes of oxygen. Oxygen is the heavier isotope, and that's oxygen 18, and oxygen 16 is the lighter. During periods of glacial buildup, the oceans become isotopically heavy because oxygen 16 is drawn off with the moisture that builds the ice sheets. During glacial periods, the oceans have a high ratio of oxygen 18 to oxygen 16. The reverse is true during interglacial periods, when the sea levels rise. Measuring the ratio of oxygen 18 to oxygen 16 in the foraminifera collected in deep sea cores provides a record of the advance and retreat of glaciers during the Pleistocene. The record provided by sea cores is very different from the model of 4 major glacial periods. The picture that emerges is of an unstable climate with many glacial and interglacial periods over the last 1.8 million years. But in the last 700,000 years, there have been 8 full glacial interglacial cycles. The climate record produced by the analysis of deep-sea cores is known as the oxygen isotope curve. Glacial and interglacial events are given numbers. From the most recent, we now live in oxygen isotope stage 1, to the oldest. If one looks closely at the oxygen isotope curve, it becomes evident that the extent of glaciation and the rapidity of climate change vary considerably. For instance, the boundaries between stage 5 and 6 and stages 9 and 10 are examples of particularly abrupt climate change. Again, the oxygen isotope curve is the record of fluctuations in global climate during the Pleistocene. Before the Neanderthals. Let's see here. In the next lecture, we will cover the time before the Neanderthals. And in this reading, we examined the evidence for the initial dispersal of Homo erectus. To understand the evolution of Neanderthals, we need to know more about what happened after this initial dispersal. We need to know as well when hominins first spread into Western Europe. We also need to know about the lower Paleolithic cultures of Eurasia, that of in the West, Europe, that in the East, Asia. Finally, we want to know about the developments toward the latter stages of the lower Paleolithic. Did hominins intensify the use of fire? Is there evidence for changes in the way tools are used? Is there artwork? Are there burials? These are questions that we would consider in the next reading.